Hi everyone, we are going to start by doing a whiteboard activity as a review. Hopefully you remember that a solution to a linear equation is and that and gives you a little bit of a hint. It's an ordered pair. So it's the set of coordinates that makes the equation true. So a solution to an equation is an ordered pair. That's important for you to remember. All right, second one, for what number of days will the cost of the two companies be the same? So you can read this part on your own, so pause it, read it. But to find when the two companies will be the same, if you think about it, one of the companies starts here and is going up. This shows their cost based on the number of days, where the second company is here. So where they are the same is that point of intersection. So you have to read they are the same at, let's see, 250 days. And then we can even read across and estimate about $5,500. So we're starting our new unit today, and our unit is all about solving systems of linear equations. Systems of linear equations, and we're going to be learning three different ways: graphing, substitution, and elimination. Today we're just focusing on graphing. We will talk about what a system of equations is in a moment, but to solve by graphing, you have to know how to graph a line. So I want to start by reviewing how to sketch a graph of a line. We need the y-intercept, so remember that's the beginning point, and the slope. Remember the slope is always the one that is before the x. So y-intercept is 4, so we have to go up on the y-axis, so this is the y-axis, to 4, 1, 2, 3, 4, you put it at, and then the slope, remember, tells us our driving direction, so up 1 over 2, up 1 over 2, down 1, back 2. And it's difficult to do this precisely on the iPad, but it would look like that. All right, I am hoping that you are taking notes, not just watching. So a system of linear equations is two or more equations used to solve a problem. It's also called a linear system. So think back to that whiteboard activity. We used a system of linear equations, graphed them, so you didn't actually see the equations, but you could have, to figure out when the two companies would be the same. So it's a system of linear equations is just two or more equations to solve a problem. It's also called a linear system. A solution to a linear system is just like to an equation. It's an ordered pair, but in this case it has to make both equations true. I have that word all there because sometimes a system has more than two equations, so it has to make all of the equations in that system true. So the first thing that I want to point out to you is how you can check. So is 2, -1 a solution? You can't just check it in one, you have to check it in both. It has to be true for both of them before it is a solution to the system. So I'm going to do this first. So remember, this is my x and this is my y. So I'm going to plug in 2 for my x and -1 for my y. So 6 plus a -2 is 4. So that checks out. But that does not mean it's a solution to the system. It just means that it's a solution for this part of it. So now we have to check the next one. So again, I'm going to leave a space for my x and my y. So my x is 2 and my y is -1. So now I have -2 plus a -3 equals -5. That makes a true statement. So 2, -1 is also a solution to this equation. Since it makes both of these equations true, it is a solution. So yes, 2, -1 is a solution. So here are the steps to solving a system by graphing. First, you need to graph both equations on the same coordinate plane. This is important. So you will be doing y equals mx plus b, plotting that y-intercept, using the slope to get to other points, accuracy is extremely important because then the next step is finding the point of intersection. So the coordinates where the two lines meet. And then of course checking by substituting it back in. Don't forget if it's an application problem, and you're not going to have many today, but if you have an application problem, you have to interpret what the numbers mean. This will be more important in lessons to come. Alright, so the first thing we need to do is graph both equations on the same coordinate plane. This first one is easy because it's already in slope-intercept form. So you start at 4, and you go up 1 over 1, up 1 over 1. Or down 1, back 1. And again, it's important that you are accurate. The second one is not as easy because it is not in slope-intercept form. So we have to add x to both sides. So 2y equals x plus 6, and then we have to divide everything by 2. So y equals 1/2 x plus 3. So we're going to go to 3, plot that point. Ooh, let me do this in y equals 1/2 x plus 3. So a separate color for you. So it's right there, and we're going to go down, or up 1 over 2, up 1 over 2, or down 1, back 2, down 1, back 2. So I can see already that point of intersection. It is right here at -2, 2. So I'm going to plug that in to both equations to see if it works, because I think this is my equation, but I don't know that for a fact. So 2 equals -2 plus 4. It checks out in that one, but don't forget to check it in both. So 2 times 2 minus a -2 equals 6. 4 plus 2 is 6. It does check out. So -2, 2 is our solution.